climate in South America and in Asia and even in Africa when it comes to food production, drought and wet weather. So it's good to know about those patterns. In this case, the people who developed the model have chosen for a three-dimensional model in the sense that you can see the current below sea level. So in fact you look at a sea floor, although the sea floor itself is missing and it might have different relief, but we look into a kind of aquarium where you can see the patterns going. I will again play it so you can have a look. And you should imagine that there's a whole large mathematical model behind it with geographic input to be able to realize this. And it's just played in 10 seconds. Okay, so I've shown you now 4 different, let's say, problems which might occur in the world. And I've shown you this by using maps. Of course, they are not just ordinary maps, they are all special maps, and I guess that's at the moment the mission of cartography and geovisualization, is to create appealing visualizations, new representations that help us depict this type of data. Changing data over time, data which still tell a story, but which allow you to explore. So indeed with those animations, and again, as we will see, animation is just one of the examples of an exploratory tool which can tell a certain story that you can query and you would like to have information. Now again, if you remember all the airplanes flying the globe, it would be interesting that such an animation is interactive, that you can click on a dot and get information. Okay, this is the Air France flight 000 going from Delhi to New York or something like this. That is additional information. So the challenge is also that the visualization is linked to a database and is linked to geocomputational capacity. So that if you have a question, that you then can calculate something and get an answer. I'll show you examples later on. I have another example. In this case, we look at the Katrina hurricane, which struck on New Orleans a couple of years ago, and we see 2 animations. One on the left shows you the satellite imagery stitched together into an animation projected on Google Earth, and the 3D image shows you the model of the meteorological and climatological people who created this, and it partly shows in white the path that was followed by the hurricane in reality, and the dots show the predicted path from the model. So here we look at model and reality, because again, if we are able to match those, we can learn and we can adapt and update our model. In addition, the coloring shows us, and again I'll play them again. The coloring shows the heat, the temperature of the water, and as you can see, when the hurricane passes, it cools down dramatically. Especially when the hurricane is at its strongest. So here again we deal with lots of geospatial data, and somehow we would like to make sense of this data. We would like to ask all kinds of questions, because at the end, of course, we would like, well, probably we cannot prevent hurricanes, but if we can better predict them, we can avoid damage. It's not only that scientists at the moment are working on, let's say, developing new visualization techniques to deal with lots of data. Another event we witness is that also people like you and me are participating in this process. We also collect our data. And one interesting initiative which is operating globally is the so-called OpenStreetMap project. That is where people collect data. I mean, many cell phones these days are include a GPS, and you can record the track where you go, and that they all together put in a database. And this database helps us to get a free database of all road networks and other information which we can use for research purposes. In this case, we look at a sample map of the city of Enschede, where ITC is based, but it's also possible to find similar maps of New Delhi, although the data content is not full coverage of the country. Some spots of the country have been covered. And what I would like to show you now again is an animation, and this animation shows you all additions to this database and updates in the year 2008. So a certain organization collected all these updates and created this animation. I would say sit back and relax. It takes about 1 minute to play this animation. And again, imagine the massive amounts of data we are dealing with. And as you can see, that Europe and North America, of course, are the most densely populated with road data, but other places are coming up very fast as well. Look at India as well, lots of data. South Africa, lots of data available. And not only are people collecting road data, but events like the Google Earth and Google Maps and similar events, they have made it possible for people to collect all kind of other data. So it could happen that a municipality collects all the schools and put them in Google Earth, or a province collects certain facilities and puts them there. So people collect lots of data, and that's all out on the internet, and it's quite interesting to see how we can use this data collected by not necessarily the professional, how we can use this in our professional world. So we link this to observations from satellites. And the people are other observers, so to say, and this combination gives us lots of strength. On the other hand, we have to deal with quality issues, and we deal again with this massive amount of data. This is an example. This is parts of Central Europe of Google Earth, and Google Earth, of course, if you have access to the internet, everybody can play with this. And this is if you just switch on every layer in this area of Europe, and you can see you get maps which are very complex. That's why I titled this slide "Why There Is Cartography," because again, this is too much to deal with. So we have to find ways that not only we can deal with the amount of data from a computational perspective, but also from a visual perspective, that if we ask questions, that the graphics we see, the maps we see,